and I'm going to take you on a journey, my journey with event sourcing. Um, what I'm hopefully trying to give you here is basically, I'm just an engineer like everyone here. I work in teams, so this is not just me. This is what I've learned with working with some really smart people. So I'm just hoping to share what we've learned, some scars, some stories, and hopefully there's enough for someone who's new to event sourcing or someone who's been on that journey before. I love sharing. I've done a couple of talks, yeah, and they're varied talks, a few on event sourcing. So that's my experience. I started at Just Eat. I came, we this is something I was maintaining from an event sourcing point of view. So if you've ever heard of Just Eat, the rest are kind of something I started from scratch with a team. So pharma, application in pharma, clinical trials. We modeled clinical trials event sourced. The talk I'm going to give you is all around payments. I'm going to introduce the domain slightly, a very complicated domain, but it's all about scale. Tesco is massive, and we were kind of taking payments at scale. And I'm going to give you a couple of stories around, our experience. Currently, I'm working contingent. I'm using event sourcing within procurement, supply chain, and I might touch on that throughout. Right. So let's start. I mean, that book on the left, right, on my left, is a book I kind of read years ago, and it's a really interesting book. I really learned a lot from that book and implementing some of that. Some of that, one of the diagrams I came across, and I thought I'd share it, is one of that one where it talks about the whole architecture, and and the architecture. It kind of talks about three different bounded contexts. This is Greg Young, right, and the team, and they talk about three different bounded contexts, and they talk about event sourcing in one. So it's actually, just to let you know, event sourcing is not a solution for everything, right? It works in some cases where there's behavior, and you kind of, I'll talk you through the journey and tell you what's good. The other book is pretty good read. So just about Tesco, for people who don't know, over 5,000 stores around the world, one of the biggest merchants. 4,000 stores in UK and Ireland. It's 24-hour, some of these stores. They're 7 days a week and 365 days a year, right? So even on Christmas Day, right, Tesco's is up, right? We don't, there's fuel pumps as well. There's grocery home stores. This is the e-commerce side of it. And it's a critical domain. If payments doesn't work in a merchant, pretty much, as fireworks go off, right? And in some cases things have to be less than, we have to do some of the transactions less than 200 milliseconds, right? And you can imagine someone's at the till waiting to to know that they can actually go home, right? So Tesco did 53.4 billion. I can break that down, but that's equates to millions, several millions of transactions a day. That's what we were doing through this system. It's a complex domain, but I'm going to try and simplify it for you, and try and describe that domain a bit. Plus, what was happening during the time when we were doing this, right, was we were moving from legacy, right? This is the mainframe. We are updating pin entry devices, moving to stronger encryption, and we were rolling out to 3 stores, 30 stores, 100 stores. When we got to 5,000, and we had to make sure legacy was working. We weren't losing any money, right? Every penny from every till had to be in the bank, right? And top of that, we had the pandemic, right? So transition from card to cash to card. There was people buying toilet rolls everywhere, and there was a slot booking. People transitioned from to e-commerce, and there's 3DS V2. So there's lots going on, right? And we were kind of rolling this out. So just to give you a bit about the payment domain, and I'm going to whiz through this. I'm going to make you experts on payments, hopefully, in a bit, right? So you got all these people in the middle, right, that are involved. So I'm going to talk about authorization. This is when we go and tap your card on that PED, pin entry device, right? You pay with a credit card. It sends it to the acquirer. This is us as Tesco. Send it to the acquirer. Acquirer sends it to the scheme, Visa, Amex, MasterCard. Then it goes to your bank. And what happens in this process, which is under 200 milliseconds, we block your money in your account, right? And there's fraud checks going on as well, right, in that whole process. And it's got to take 200 milliseconds. We go and basically block your money. And we have got 3 days from that point onwards to take the money from the account, okay? What happens sometimes, things don't go right, yeah? The PED will issue a reversal if the authorization goes through, right? Then we have to make sure that, we reverse that transaction. It goes back to the scheme. The scheme sends it to the bank, and if something goes on, we unblock that money from your account because we got to take that payment again. We got to make sure that we don't double do that as well. All right. Also, right, there's a whole process that goes on afterwards, right? After you walk off with your groceries from the shop, right? Basically, this is what happens, right? We take the batch of payments, we send it to the scheme sends it to the bank basically then issues funds, the scheme pays the acquirer credits the merchant, we get the money, and everyone's happy, right? So the money is now in the merchant's account. But we've got 3 days to do this. However, when you're dealing with millions of payments, we have a 2-hour window here, and it's not kind of the merchant, it's actually the banks are very antiquated, very old technology. So 2 hours is a good thing for the bank, right? What happens afterwards is we do reconciliation. We make sure that the scheme tells us what's in the bank, and then we go and reconcile the payments, make sure that every penny from the till is in the bank, and if something didn't end up in the bank, we got to find out which till it came from, right? So it's got to be almost in real time as well. We got monitoring, alerting around the whole thing. So I'm going to give you a brief intro into event sourcing. I'm going to whiz through this because this is the event sourcing conference, and I'm not a complete expert in event sourcing. This is what I've learned, and this is my view of things, and I'm trying to go and pick something that's relevant, right? So if you look at traditional 3-tier architecture, people talk about stateless servers. Yeah, we can scale with stateless servers, but at some point they use a database to hold global state, right? And state is really bad, right? In terms of it's been fed by relation databases over 40 years. Storage was really expensive, so we just reused storage, right? But you got to remember that overwriting data is like throwing money these days, right? So if someone adds something into basket and removes it from the basket as an example, adds it back into the basket. If you overwrote everything, you'd lose some interesting information of why someone removed something from a basket, right? That's valuable information, right? And then you got the database contention side of it, right? If you got lots of processes writing to shared storage, you got lots of things that can go wrong, right? And then if you really want an audit log, you've got to write all these additional data, right? So state is painful, right? But if you think functionally, right, in a functional way, right, or even about data storage, you can treat storage as immutable, right? Storage is cheap, right? And data is valuable. So never delete, just append it, right? Think of Git, right? Everything we append to Git, right, as a Git log. And then it removes the problem of the database altogether, yeah? And you can just relax. You can forget about storing state. And this is where event sourcing turns things around. And I'm going to take you through that journey, right? And what you store pretty much is an event. And events are really, really simple, right? They should be simple, right? And you got to treat them as immutable. They never change. You can't go and change the past, right? The same way you got to think about these events. You can never change them. Once they're written, that's it, done, right? They've happened. You got to also make sure that in our case they're serializable, right? So we can write them to storage. And versioning, I'm going to tell you about versioning. You got to make sure you version them because things change, right? We're engineers, right? We learn more about things, and we got to make sure that what we build we can change as well, right? So you got to make sure you version these things, and I'll tell you what happens when you don't, right? And the main important thing, audit, especially if you're taking payments. You got to make sure those events happen in the right sequence. Otherwise, payments doesn't work, right? So if you had to represent it, it's pretty much like this. Our flow was, you got authorize as a command on an aggregate, and then you got the authorize. It could be failed as well, right? These are events that are raised. You got to make sure that it's not authorized before, right? That's an invariant, right? So if it's authorized, fails. Same thing, reversal, we got to check it's authorized. If you're settling, this is painful, right? So if you're settling, you got to make sure it's authorized in some cases, right? Sometimes you don't really need an authorization for a settlement, right? For example, a refund. And you got to make sure that you've never settled this payment before. Imagine if the Tesco had to go to your account and take your money twice. That would be in the papers, right? It's pretty serious. So yeah, we got to make sure we only take the money. And at the end of the day, we got to make sure it's reconciled. So we got to make sure it was settled. So there's a lot of cases we got to go through, make sure things happen in the right order. And there's a lot of logic built into here to make sure things don't go the wrong way. Okay, so storing events. This is your event store. You can use pretty much everything. It's so simple. You can use a log file. However, when you're doing it at scale, you got lots of options. We actually went for Cassandra, right? And I could do a whole talk on why Cassandra, and Cassandra's pretty amazing, to be honest, for kind of in this scenario. And I'm going to assume like we could talk about Cassandra in a separate session. But yeah, we built our own. Because it's pretty simple, right? You do need a set of fields, aggregate ID, timestamp, and we introduce a sequence number, right? Now, why a sequence number? Because we got to make sure they're in sequence. And there's a couple of cases I'll talk about in a bit, right? Now, the sequence number is pretty much if you got a distributed store like we did, right, across multiple data centers, right? Cassandra offers like things like time UUID, but we actually had to make sure that the sequence numbers were going up because, if you're on multiple servers, milliseconds, time syncs, things can go out of order pretty badly, right? If there's anything wrong with the infrastructure, right, or anything on that end. So we actually relied on sequence numbers to actually make sure things are done in sequence, right? And I could go a bit more detail in that in a separate talk, but that was pretty much a lot of work on that end. But this is what happens, right? This is how kind of the events look like. You can aggregate ID, you got timestamp, you got sequence number, the event types, and the serialized event. That's pretty much it. You can hold this anywhere, right? It's a log file, right? But in our case, we were using Cassandra, right? Also, we were holding multiple representations of it, right? So you can imagine what is an event stream. If you look at an aggregate route or a store across one payment, it's just a stream of events against that payment, right? And we actually store them in time buckets for ourselves. And we use kind of watermarks to kind of take us through that stream. So you can look at it as a continuous stream of events across the whole of Tesco, or you could look at it as a continuous stream across one payment, right? And we kind of had two views, right? And if you use something like Kafka, NAT streaming, or Kinesis event hubs, or even right now we're using PubSub in Google with ordered kind of events, they kind of support this kind of architecture, right? And they basically so what does the architecture of event source system look like? And a lot of people will be familiar with this. You got the traditional three-tier architecture, but event source system is almost kind of a command query responsibility segregation. I mean, you can use CQRS without event sourcing, but pretty much this is the kind of pattern everyone follows. You got a set of commands on the command side. You kind of rehydrate, aggregate, apply the command, raise events, goes to the event store, and then those events kind of get played back, right, into the query side. Now, they are all projections, right? And the query side projects into various view models, right? And I'm going to talk about this a bit more on kind of context on the payment side of it, right? But if you look at it in this way, you just have a set of events that you're storing. You create the aggregate, the state, the first state. You apply subsequent events, and you end up with the states as you go along, right? You can actually play back in any way, right? So, but this is pretty much it. This is event sourcing, right? So why do we care about states? We mentioned that we don't care about states. Then we say, oh, we care about states, right? And the reason you care about states is because you need to make sure that let's say your payment was in a certain state, right, before you accept a command, right? So you rehydrate the aggregate, and you need those decisions are made, right, on that particular state internal to the aggregate, right? And then you also have to display data to users, right? People are using this, right? You need to do that in real time, especially when with our scale, you have to make sure everything is almost in near real time. And then you've got analytics side of it. You've got to create summaries, and you can also do pattern recognition. For example, fraud, right, is a great example where you can look back across the stream and find patterns and then raise those. And these are all stateful as well, right, in a way. So I thought I come up with things you should do and things you shouldn't do, and especially when you're doing things at scale, right? Unit test the aggregate. Tests are critical, right? So, test the invariants, test every command. And more often, expect those commands to come out of sequence, right? Don't assume that your commands are going to come in a particular way. Things happen in those systems that, especially if you're using pub sub and, whatever, that you've got to expect things to happen in a certain way, right? And you've got to try create, ensure that behavior is tested as well, right? But it's pretty simple to test and aggregate, right? And you can use any in-memory store, right? And for if you want to do edge-to-edge tests, right? It's actually really easy to swap out the event store for an in-memory implementation, right? So kind of supports really good testing, right? What about versioning? Now here, things can happen really, things can go really wrong, right? If you don't do this. So, you can change enums, right? Especially if you're using kind of some programming languages. You can change the structure event. Anyone can do that. If you're using an IDE and you're just using refactoring to basically move forwards, sometimes the IDE does magic stuff right under the hood and can change things. But you got to make sure you got the tests in place. You got to be diligent about it. And when I say diligent about it, right, you have to take the additional steps. You can automate to some extent, but I'll show you what we did, right? There's a good paper by, Versioning Event Store. Read it, right? Greg Young, a master at this. Please read a lot of the docs, a lot of talks by Greg Young. Really, really interesting. And, that's he's talking from experience, right? So we did this, right? So, store the snapshots, right? Version 1, version 2. And every time we actually, this is the diligence, we changed an event, we went and created a version for it, right? And then we wrote tests around the fact that, can we serialize these, right? Does anything go bang, right? And you've got to make sure you write these tests because these tests are a great savior. And I'll show you what happens when you don't, yeah, or sometimes, when you're not expecting things, right? Um, Unit tests for idempotency, right? Yeah, make sure you replay your commands. Things can come again, right? I mean, and they can be played again, right? In certain scenarios, in a distributed system, you have retries, right? You have things that are hitting you and making sure they're resilient. Things can go wrong in the network, so idempotency is really important, and not only in just the aggregate side of things, not only on the write side of things, but also on the read. And I'll talk about that in a bit, right? Bottom line, don't change the state of the aggregate. You can handle it based on what you're doing. Raise a metric, throw an exception, do nothing, right? In payments, we don't do anything, right? Because, there's kind of security reasons for that. However, that's a choice, but don't change the state of the aggregate, right? What about recovering from errors? And this is an interesting one, right? So people talk about this deleting events. Never ever delete events, right? If something goes wrong, right, in your system, right, don't even think about doing something to the event store. Never touch it. I'll show you what you can do, and this is what we did. And this is a scenario. You just create a new event, right? And this is what we did. So, for example, let's say we authorized, right? And it's an authorized state that the payment, we raised an event, and maybe something went wrong with the settlement, right? Yeah. What happened is basically something went wrong. We ended up in settled state. Now the payment is in a weird state, but something went wrong around, the event itself, right? And then you basically some other event comes in, right? What happens? Do you delete that settled event? Do you change something? Do you rewind it? What happens? Actually, what we did is create another event settled in error, because that's actually what happened in the real world, right? It was settled in error. We create an event, add it to the aggregate. It puts the aggregate the payment in the right state, corrects the state, but it also records what happened, right? So this goes at the end of the stream, so we can also handle it in the projections, right? So it's pretty much handling errors. Don't delete, never delete. This is one way of handling it, right? There's other ways, but when you're doing it at scale, right, there's ways you can copy the event store, you can do other things, but to be honest, when you're doing things at scale, this is pretty much a savior. You just you just have to move along, right? You can't change history, whatever happens, but you can change the future. That's one way, right? Projections, streaming at scale, right? So I'm going to talk about projections here and some learnings, pretty much why, right? So we've got millions of events, right, coming through the system. How do you query that, right? So how do you query a system? You know, when I say we were doing millions of payments, each payment had 15 to 16 events, right? I just showed you a simplified version. So you can imagine 15 million times the million events, right, a day, right? How do you query that, right? And how do you make sure that you're doing it in real time? How do you know what's happening, right? How do you ensure that when you're querying, things are fast, right? And this is where projections come in. This is where you kind of build your read models. And as much as you want to scale on the right side, you probably want to do this on this side. And you got aggregations, fraud detection, financial reporting, reconciliation. Are we losing any money, right? Where is the money going, right? Diagnostics. When something goes wrong, where can I drill down, right? Which till was it? Which store was it, right? Um, and if you think about projections, think functionalist, right? Functionalish, in a way, in a functional way, right? You're playing back an event stream. You can create another event stream, but you can also, do something with that, right? So in this case, it's ish because we're creating state, right? And you can project out into various forms, right? So you can play that into a graph database. You can play that into Elasticsearch. You can play that into SQL, right, for reporting. And you could actually be in one data center and play it into a different data center. You could play it into, you could be on premise playing into the cloud, right? Or you could be in GCP playing into AWS. In terms of like, you can actually use multi-cloud architectures because, different clouds give you different advantages, right? Different services. So you can actually leverage that. And this is the nice thing about projections, right? This is not really about event sourcing, but this is a really nice book I read around unified logs and event streams. Really good book. It's a good book to read and give you. It takes you into that mindset around projections, right? It's just an event stream. Think about being on Unix and catting a document and knocking it or setting it. Just playing that stream is functional, right? Playing a stream of events into another stream of events into another stream of events, and then transforming it, right? Now, testing projections is really easy because all you do is use an in-memory event stream, right? You basically play the events in the order you want them to be in your tests, and then you expect what happens in your view model, right? Um, you need to test for incomplete aggregates, especially if you're running a system that is 24/7. You can't say, I'm going to start on event number one, because you might never see event number one, right? Especially in some cases, right? And then test for idempotency, right? Because the thing here is some of these event projections take so long to build, right? The worst thing can happen is, something goes wrong, then you have to restart the event stream, right? And you can do that. You can rewind the event stream. But if you basically idempotent, right, in your projections, you can rewind the event stream to any point in time, right? And I'll show you how you can use the sequence number to actually make sure you're idempotent, because you're going to make sure that at any point in time you can blow away your read model and rebuild it, right? So this is how you build a representation in our world. You play the event stream in order, right? And it's important it's in order, right? And you basically build a kind of a snapshot, almost. So now you're almost building a state, and then you can further aggregate it, right? And this is important because sometimes, these events are not your standard pub/sub events which contain a lot of information. They are just specific to that event, and you normally almost need to build a payment representation on the or your representation of your aggregate on the read side of it, right? So you kind of do things in a stateful way on the projection side of it, right? And you can build additional kind of views of that, right? But this is one projection. Now, how do you scale projections, right? What you can do, you can partition by the aggregate. So in this case, imagine each payment came in parallel to your projection. And it was basically all the events within that payment are ordered. So that's the important bit, right? It doesn't matter if you run the payments in parallel, but within, or the aggregates in parallel, but within the aggregates, every event has to be in sequence, right? And you can actually scale out really well this way. You can actually, and this is pretty much Kafka, Kinesis, NATS, whatever you're using, you can partition by an aggregate, and basically it will give you those events in order, right? And this is how we kind of scaled, right? We scaled to multiple services, but we played the aggregates in parallel and processed them in parallel, but the events within the aggregate were in sequence, right? It's a good model to scale, right? Now, what happened when you're building a projection at scale, right? Sometimes, projections, like when you're playing millions and millions of events, can take a long time. And the bottleneck, to be honest, is always the thing you're projecting into. It's state, right? So if you're writing into SQL, right, it is painful. If you're writing into Elasticsearch is really good for querying, but the right side of it is really, really expensive, right? And it's slow, right? So you'll always have a bottleneck when you're creating the projection, right? And that's how life is with state, right? However, sometimes you really need to build a projection at scale. You can do that in this way. Sometimes you just care about, let's say I want to restore the last week's data, right? But I want maybe 6 months worth of it. So what you can do is start the projection from a week ago and play that data. But then you can start another projection, right, on that same read representation that starts 6 months ago, and that can play catch up. And you can start many of these because you've kind of written your code, you're idempotent, right, and you can basically handle events at scale, right. You can basically start these read representations, a multiple of these, right, and you can actually play catch up, but you can actually restore really quickly a read model. And we employed a lot of this techniques to actually recover. Sometimes we had to rebuild read models because we just changed the logic, right, in the read representation. I'll show you how you can do that as well. Idempotency is really important in a projection, and that's where we have the sequence number, right? Every time we created the snapshot, we remember the sequence number. We're at sequence number 2, right? So imagine if we had to rewind the stream and replay it, we would just skip anything that was up to sequence number 2, right? And then carry on with 3, 4, 5. So you can actually rewind the stream, replay it back, right? It doesn't change the way the projection works, right? Or it doesn't change the projection at all, right? And the nice thing is, like, you've got to be idempotent, right? Because you don't know, you might need to rewind, you might need to recover, you might need to do things, things happen in the system, right? Yeah, and unexpected things happen in a system, right? In a distributed system. So this is a nice thing we actually did, was to actually remember the sequence number, right? What about event streams? You can actually take an event stream and use a projection to create another event stream. And this is something we're doing at our current place. Like, we're taking an event stream and generate another stream, which is probably a monitoring stream or a changes stream or whatever it is, right? But this is like your standard functional way of thinking, right? You just take a stream of events and create another stream. And you can keep on doing that, right? You can create another stream out of the other stream, and you can just play those events back. You can store that stream somewhere as well, and you kind of keep on going, right? It's a nice mindset to be in, right? And the applications can be interesting. So what that means really is that don't rely on projections, one projection to answer your question. You could actually use one projection, right, to create another stream, to then use another projection from that stream to create your final answer, which is quite nice. It's kind of a Unixy way of thinking around things, right? Now, what about rebuilding things, right? So imagine you've made a change and you've added, I don't know, fuel or something, and you want to rebuild the views. What happens? What you can do, you can actually keep your old projection going, right? And that's going to be based on where you are currently, and your app points to the old projection. But what you can do is start up a new projection with a new code, right? And that basically builds out the new projection with a new code, replaying all those events. And then once you're happy and you've caught up, you can then point the app at that, right? And this is the nice thing about evolving the whole projection side of it. You can just basically update projections and keep on going, right? Okay, and your app now points to the new one. You can kill the old one, right? The other thing you can do with projections, and we did this, imagine we're taking millions of payments, right, a day, right? Now, an event storage is inexpensive, right? But you can imagine storage keeps on growing, okay, and it's going to grow forever. You can't have that either. There's a finite. Sometimes you got to think about, how long do I need my aggregator around for, right? How long do I keep it, right? And what you can actually do in this case is you can actually use projections to archive the event store. So, right? So what you do, you play the event stream, you take your projections, and you can store it somewhere, right, in long-term storage. Then what you can do is go back and treat your event store, maybe shard it, take things offline, which we did, right? And I'll show you what we did with an ever-growing event store as well. Okay. The nice thing about projections, you want a new feature, you build a new projection, right? You want a new app, you build a new projection. And that's the nice thing, you don't have to go back and change anything in history because you have an event stream, right? You can build new applications built or based off your history. And it's a very nice feature. And we built a lot of things, which we didn't have, tools around this feature. Okay, the idea of, we could just play back an event. So some additional stuff around projections. It's okay to duplicate data. Storage is cheap, right? So don't think like I've created a projection, I need to go back and bolt on something to it, right? No, just create another projection. You might have duplicate data in the projection, but it's probably very specific to that particular view, right? So just it's okay to duplicate data. It's fine, right? It's also, you know, okay to blow it away and keep them independent. Don't have one projection off another projection. When I talked about a stream talking to another stream, that's still one projection, right? However, keep them independent, right? You have one projection that does something. It might be duplicated data, duplicated code potentially at some point, maybe in the library, but at least it's independent for that particular purpose. And also, it's okay to blow them away and rebuild them from scratch, right? You got to have that mindset. The source of truth is actually the event store, right, or your event stream. You can just blow away the projections and rebuild them. It doesn't matter. They're inexpensive, right? And then keep them simple, right? Just keep them simple, as in, it's okay to duplicate logic, right? It's also okay to generate a slightly different projection, right? It might, but when I say different slightly, at least the new projection is its own thing. If you bolt on and bolt on and bolt on, you end up with a mess. In this case, it's just easy to start with a new thing, right? Okay. Now, continuous delivery, there's some gotchas here. If anyone's doing continuous delivery with event sourcing, there's some things you got to watch out for, right? For example, versioning, I mentioned versioning. If you're doing canaries or scaling out, as we did, a canary is normally a set of servers or instances of your code that you deploy to, right? And you test around. Takes a small portion of your traffic, which is what we did at Tesco. We took a little portion of the traffic to the new code, right? And whereas the old code is kind of doing the whole of Tesco, right? A little traffic goes in. If something goes wrong, we kill the canaries, right? It's the best way of deploying in a less risky way, right? And basically after the canary is happy and we've monitored it, we roll it out to all the other instances, right? Now, in some cases, if you roll out the new version, if you have a new event, let's say you added reconcile to the aggregate route, and you roll out version 2, right, to your canaries, it's going to write to the event store the new event, right? The old instances of your servers are going to try and rehydrate that aggregate, and they won't know what happened to that, what happened to that event, right? What's that? That's something new, and things go wrong. Bang, you have issues, right? So if you're doing scaling out and you got new versions and old versions, mix of it, and you decide to add a new event, things can go wrong. Now there's two scenarios you can recover from this, or you can do in advance. So one thing you can do is don't write the logic around your aggregate, but roll the code out with a new event, right? So you know that what's going on is you're going to add a new event to the aggregate, roll the code out, so at least the aggregate knows how to kind of ignore it, right, in the first instance. And then you're doing two deployments, right? And you can deploy in that way, right? The other thing is just don't do canaries in production. See if you can roll out. If you roll out, there's no rolling back. You got to remember with event sourcing, as soon as that event is written to the event store, there's no rolling back, right? You just have to roll forwards. Okay, that event's written. It's history. Um, so what about projections? Same thing can happen with projections, right? You roll out a new version, your projection doesn't know about that new event, it goes bang. But in our case, if you look at projections, you never ever think about every event you need to handle. For example, if you're doing reconciliation, you probably care about all the events. But if you're doing fraud detection, right, you probably care that the payment was made against a particular card, right? So you don't need to look at all the events. And in our case, what we did, we just ignored any event that came in that we didn't know about, because that projection just needs to work, right? It doesn't need to know about any new events. It's a very different way of thinking. Or you can just do what we talked about earlier, deploy it with a new event in place, and then roll out the changes to the right side. Okay, right? So there's some issues you need to watch about in a continuous delivery microservices world. Fail in CI before you fail in production. Write some really good tests. Write some unit tests, right, around the aggregate. Make sure you test all the invariants. Testing, testing, testing. Can't say much more about that. Test for backwards compatibility, right? You sometimes have to roll out services twice, right? Do a little change. Expect things to go wrong. Or what may go wrong, and then deploy little bits and pieces. Keep on going though. Don't stop deploying, right? And you cannot deploy to canaries. It's hard unless you do what is mentioned, is deploy some changes forward, right? And what we did was basically ignore events in the projections, right? Never ever delete events or handlers for these events, right? Again, make them obsolete. Maybe you don't care about those events anymore, right? But don't ever delete them. Don't ever even remove the handlers from your aggregate, right? It's a no-no, right? Okay. Monitoring and logging. How do you monitor something like that, right? So there's two ways of thinking of monitoring. You've got operational monitoring is, am I doing payments okay, right? Am I taking payments? Am I taking money, right? And you need log monitoring at that level, right? And this is by application domain services. And monitoring is all about happy path. Is my system actually working? On Christmas Day, when traffic goes down and people, some of the stores are shut, is everything still working, right? um, you need counters, you need durations. Are things slowing down? Are things getting, you just need to know. And then you've got the diagnostic monitoring at the low level, where you can now go down at a low level and say, from a payment services, the infrastructure, the encryption, the Cassandra layer, the event store, are things are working, right? Is my event store having issues? Things can go wrong with writing millions of events into a store, right? You need to make sure your infrastructure is being monitored as well, right? And you need to drill down at some point. When things go wrong at the top level, you need to be able to drill down and have a look, right? Use StatsD, right? And Prometheus, right? StatsD, UDP packets, fire UDP packets. They can be lossy, but at least they tell you what's going on. Use a time series database, right? And write millions and millions of events, right? When I say events, millions and millions of metrics, basically stats, right? Write loads of them. Okay, stats are inexpensive. They're not logs, right? They're just counters and gauges. Okay. Then on the logging side, the event store is a log, right? You can look at the log, right? And that's what we used to do. Something goes wrong, you can just load up the payment, look in the event store, right? It is a log, yeah, pretty much. And then we also focused on negative logs, right? In terms of like, we never did any happy path logging, in terms of that. We only looked at warnings and errors, maybe debug, which was turned off, right? And use an inverted search index, use structured logging for logs, because you can write things out, maybe pass over your domain events, or maybe fatten up the domain events for logging, right? And give you a bit more context. But yeah, use the structured logging, okay? By the way, ES is not a solution for everything. And I wanted to kind of talk about this because, there are some cases in Tesco we chose event sourcing for some bit. And we thought afterwards realized actually, this is not event sourcing, right? You can tell a smell, right? You might be able to start on something and then, the smell's coming around from the way you develop stuff. By the way, event sourcing doesn't seem to fit. Now, it's okay to change, right? If it's a CRUD based thing, change it back, right? Saves you a lot of headache, right? No, when I say headache, it's in that area where you're just having event sourcing just for the sake of event sourcing. It's not going to change back. And the nice thing about event sourcing going backwards, it's easy, right? It's a snapshot. Now, when you go from snapshots to event sourcing, that's a different story. But when you're going the other way around, it's easy. So if you ever find that smell, go for it, right? And move back. It's fine, right? So some interesting scenarios, if you're dealing with lots of events, right? Archiving, right? So what happens with a big event store, right? Where you're taking millions of events, and you probably don't care as much over time what happens to the payment. Payment, the money's in the account. Do you care about it after a while? Actually, in some cases, we do have to care about it, because some tills can send payments afterwards. They can be offline. The cashier can go home, right, and they come later on. But after a while, there's a window where you probably take things out of the event store, right? And especially if it's ever growing, right? It's not like you have infinite capacity as well, right? So you can actually do this. You can actually take shards offline. So you can actually write a marker event, which is more current, for the purposes of idempotency, right? And then basically just take parts of your shard offline, right? So you can it's still on disk to some extent, but it's probably not, or maybe you can move that off, right? But it's not part of your event store anymore, right? And these, I'm talking about like really, really old events here, right? But what you do, how to do that, you actually write a new event to make sure that actually, you know what, I'm at that point where I can actually just archive of this event. And how do you create that event? From a projection, right? You project the event stream, and you figure out, actually, this is the point in time I want to basically take that payment offline, or that aggregate. I don't care about it, right? Projections, again, this is an old story. I started talking about state, right? You've an event stream, you got projections on that event stream, you're writing into a SQL database, but potentially, and you got to watch out for these things, right? You're writing state again, and you have all the issues around state, right? Locking and stuff like that. And we had loads of issues. And you got to remember that, you're writing millions and millions of updates or deletes or inserts, right? And the transaction logs. And in the case of some SQLs like Postgres, you have, kind of these kind of records that it creates, because it's also internally almost immutable, right? It basically creates all these tuples that you've got to basically tune the SQL engine to cope with, right? But it's all about state, right? And it's painful, right? But in some cases, you just have to do it. And of course, SQL has storage constraints and its scaling constraints. But yeah, it's always going to be a bottleneck. Projections, pretty much, whatever you project into, if it's state, it's going to be some bottleneck there, right? Thank you very much. I thought I'd finish early. Thought I'd share a bit about the journey. I'm actually at contingent right now. We're kind of using event sourcing, knowledge graphs, AI, natural language processing, pipelines, quite interesting stuff. And if you're interested in, if you're interested in learning, just ping me anytime. And also, yeah, we're recruiting. If you want to, feel you want to work in this area, just give me a shout. Thank you very much. I thought I'd finish early and take any questions if anyone's got.